Welcome back. In this video, we're going to talk about the p-series test. But first, I'm going to go back to some work we did when we were, in the last video, when we were doing integral test. And I just want to compare these two examples, A and B. We saw that series A converged, whereas series B diverged. But if we actually look closely, we can see the mechanism by which this is happening. It's really happening right here in the antiderivative step. Okay, so see on the left-hand side, after antidifferentiation, the power of x was still negative, which caused the b to go in the denominator, and as b went to infinity, I was able to take that limit and have it exist. Whereas on the right, after antidifferentiation, the power of x became positive. I had a b in a numerator going to infinity, and that caused divergence of my integral, causing divergence of the series. So what we're seeing here is if it's just a very easy power situation like this, and our power is negative enough that when we add 1 for that antiderivative, it's still negative, that causes convergence. So let's think about that. I need to be able to add 1 and still be negative. So that would be more negative than negative 1. Okay, so if the power is more negative than negative 1, we're going to have convergence. Now, the p-series test as it's written, like as a theorem, is a little bit different from that. We're just going to assume we've got 1 over n to a power, because it's way more common to encounter a series written like that than written as a negative power of n. So this thing converges if and only if p is greater than 1 for exactly the reasons I was just talking about, but I'm not going to get into like exactly proving it or anything. I'm sure I've proved that at some other point in some other video on my channel. Okay, so the first question is, which of these is a p-series? And I think it would actually be easier to say which one is not a p-series, and that would be this one right here. You just kind of look at the pattern up above, 1 over n to a power. That's what a p-series is. Okay, so again, I've got this missing equals sign that happened elsewhere in these notes. And so I'm going to say that this one is not a p-series. Okay, and for the ones that are p-series, we're going to determine whether they converge or diverge, and you're going to love this test, at least as far as the justification goes. All right, so for A, oh, and I'm gonna make a change to B. Hopefully you see that in your notes book. Changed it on the original, but didn't change it on the one I'm writing on here. So which of these is a p-series? A and B are p-series. We need to rewrite A and B as, 1 over n to some number, so we can easily compare that to 1. All right, so 1 over n square root of n. N is 1 power, the square root's another half, so that'll be n to the 1½ or 3/2 power. You can write it however you like. Okay, then we go back up here and thinking about A, I'm going to say, all right, converges if and only if p is greater than 1, which in this case it is, it's 1.5. So I'm going to say A converges by the p-series test, and the justification is going to involve the value of p and the fact that it's greater than 1. There we go. That's all we have to say for the p-series test. This is great. We really like that. And for B, I'm going to say, first rewrite B as a power of n, so that would be n to the 2/3 in the denominator. And then we're going to look at that power and say, okay, well, if p is not greater than 1, then the series is not converging. So I'm going to say B diverges. And I'm going to be honest with you, in the p-series test, we don't really need to have that. We need the value of p and the condition on p that causes the thing to converge or diverge. So we're going to report the value of p, that was 2/3, and the fact that that is less than or equal to 1. And another reason to like p-series test is that that's all there is to say about it. I was thinking about, do I do another example? But no, I've shown you one that converged, one that diverged, shown you the justification, shown you one that's not a p-series. That's all you need to see. So that's going to be all for this video. Thanks for watching.